Great, so I think Suzanne deserves another round of applause for bringing us together in a difficult year, like she said. So thank you for all you do for this community, Suzanne. And I think everyone here, all the entrepreneurs, all the artists, all the biologists also deserve a round of applause for all the accomplishments that you've made in 2023. Really an incredible year. So kudos to you all. And our field of biofabrication really went through a critical turning point in 2023. At the same time, we saw a failure of a well-known biomaterials company that had a flawed approach. And this was a sign that the market is thinking beyond short-term greenwashing. In 2023, this field transitioned from hype to reality, and it's because so many of you overcame major hurdles, as we did at MycoWorks. So what I want to talk about today is this. What does a biomaterial need to be in order to make it in the world? I'm going to answer that question by talking through three things: quality, sustainability, and scalability. And I'll do so under the framework of leather, though the same question can be asked by any of us for any material. Should our goal be to replace existing materials or to leapfrog them? Animal leather is an amazing material. It's a material that provides a connection to the natural world that no other material does. And so as these new quote-unquote vegan or plant-based leathers hit the market, consumers ask themselves, should I sacrifice the amazing qualities of animal leather for values? Is this new vegan leather thing really better? How can it be better when it's plastic? Well, we have all been hard at work growing the future of materials. Consumers have begun to get their hands on this polyurethane vegan leather, or materials with bio-ingredients that still feel like plastic because they mostly are. They're not true biomaterials. And consumers are confused. Now, there are a lot of opinions in this room alone on whether leather is doomed or will continue to boom as luxury brands grow by double digits year after year after year after year. But picking a side on this subject at this conference is missing the point. And that's because what leather is mutually exclusive from whether new materials will get adopted or not. Leather does not have to have its own problems for a new material to take off. In other words, a new material will not take off unless it can stand alone with its own unique properties. So let's talk about quality. Here, to use, I think some other jargon that folks might be familiar with, this would be perceived quality as opposed to functional quality, which we'll talk a little bit about later. So what is it that makes animal leather so amazing? What gives it quality? It feels alive with its rebound and its warmth. It's not a sealed, homogeneous polymer. It has directionality, it has grain, it has porosity, and it changes with time. And some of these things are often dubbed bugs by an industry that's become so accustomed to plastic, but they are features. They are what make animal leather unique and valuable, 10 to 100 times pricier than plastic leathers. Why? It's because leather is not a uniform mixture of multiple constituents. It's not a fiber or protein-based material. It is fibrous protein. Collagen molecules in leather don't exist in a random structure. They are wrapped around each other in a triple helix, which then form fibers, and it's this structure that leads to leather's amazing properties. So what if there were a material that had a similar structure, but a material that furthermore could be grown at will and tuned, and resulted in a similarly fibrous structure, and so without the need for plastic, because its own cells gave the amazing hand feel and other emotional and physical properties of leather, but with additional advantages. This is what we've been working on at MycoWorks. This is Fine Mycelium. Because for Fine Mycelium, which we make via manipulating mycelium cells as they grow to get a tensile strength 10 times that of naturally occurring mycelium, plus its amazing hand feel, we generate a structure of cells that's denser, more intertwined, and fibrous. It's not leather, but it shares something with leather because of its structure, which is this quality. So of the three things that it takes for a biomaterial to make it to market, quality is the most important trait because cellular structure is the key to desirability. And with fine mycelium, feeling is believing. But it's not enough. A modern material also has to be sustainable, which I'm proud to say Reishi is. And sustainable, responsible, however you interpret that word. That word means a lot and a whole, little, all at once. But however you interpret it, Reishi is an incredible material. Last year, we published a peer-reviewed LCA to show that fine mycelium has a remarkable sustainability profile, a super low carbon footprint, for one, plus very little water needed, a chrome-free, super fast, clean tanning process, and these are but a few of its many sustainability traits. Another amazing one is that no deforestation is needed. So we're primarily using waste. We use waste sawdust as the input. And because of this incredible fact, our full-scale plant was just designated by the state of South Carolina as a solid waste recycling facility. Really amazing. So speaking of this plant, there's a third thing required for a biomaterial to make it, and one that's really, really, really hard. Really, really hard. Scalability. So there's been this ongoing debate in our field about what type of biomaterials processes can scale, right? And you have roll-to-roll processes, for instance, that many in this industry are familiar with. It's how textiles are made, and it's how very inexpensive materials can be made, or materials can be made inexpensively, I should say. But there are many roll-to-roll processes that result in incredibly expensive materials as well. Just look at semiconductors, how certain microchip processes use roll-to-roll manufacturing, but are not cost competitive whatsoever for an industry like fashion or luxury. Conversely, batch processing, which often is equated with something that might be a little bit more artisanal or expensive, batch processing can be incredibly economical. You look at a process like baking bread, which uses a high temperature, energy-intensive thermal process, an oven, and manual labor, and is nonetheless incredibly economical. So what we have found at MycoWorks is that for biomaterials, batch processing is a feature, not a bug, because it allows us to have control, both on the inputs and during the process. And this is the key technology differentiator that we've developed with fine mycelium. We manipulate our mycelium as it grows in stackable, simple trays, no gases pumping, just a stable environment that the mycelium creates within the trays, spending most of its time just sitting on a shelf, but with the opportunity for designed interventions. So looking at our process in our California pilot plant, I want to offer everyone here the framework for looking at the economics of a batch process the way that we did. First, with any material, there are three major inputs, right? You've got labor, energy, and raw materials. And for classic materials, metals, glasses, ceramics, things like that, it's typically split a third, a third, a third. But with mycelium, because the raw materials, waste sawdust in our case, is so cheap, and because fungi like the dark, relatively temperate environment, energy costs are really low, we find that in the United States, about 2/3 of the cost is labor, and the rest, the remaining third, is materials and energy. So your process could be very different, right? If you're cell culturing, your raw material input cost is extremely high. Every process is different and unique. So coming back to mycelium, if the biggest fraction of the cost is labor, why not automate it? And that's exactly the question we've been working on at our pilot plant. Is full automation needed? Do we even want full automation? What needs to be true to make this process fully scalable? We found that it's been about reducing, but not fully eliminating the time humans spend with the trays, reducing to just the quality time. So quality time, something that we all need to understand in manufacturing, as in our personal lives, right? You can spend 18 hours of your day with a loved one, find that being in the same room, working on your separate laptops, you just get stuck in scaling those days into the rest of your life, or you can spend an hour and a half at dinner, making eye contact, talking, and the rest of your time gets freed up for work and play. With Fine Mycelium, which needs to be loved as well, we found that at our pilot plant, it took 18 human hours to produce one tray. It's a big number, and it's way smaller than it was before. Right? It's a big improvement. It was a big improvement. It's still a big number. And so we spent years at our pilot plant. We opened the pilot plant in the pandemic in 2020. It was hard. We spent years at that pilot plant looking at that process and asked ourselves, how much is actually quality time? Can we get it closer to zero? Do we want it at zero? And what we found was that no, we don't want the human touch to go to zero. With zero human interaction, we lose some of the key aspects of the quality that make our material so loved by those who ultimately feel it in a finished product. We have processes that require a fine touch, simple but important decisions, a true savoir-faire, a craft and a love that our founders, that Phil Ross, spent decades developing. So the result is that by taking the human participation out of moving trays and lids around, but keeping the interaction with the organism itself, we could preserve and even improve the material's quality while removing a factor of 14 out of the human time needed to make a tray, to go from 18 hours to 1.3 human hours per tray. So what does 1.3 hours cost? Well, hint, it's very scalable, it's very economical. And now that we're harvesting about 13 square feet of fine mycelium per tray, you can see that in most places, making fine mycelium can be very economical. So, I'm super excited to offer all of you one of the first glimpses inside our new full-scale plant, which is MycoWorks, South Carolina. A project we kicked off in August of 2022. We began operating just in September of 2023, and in late November, just a couple months ago, yielded the first sheets of fine mycelium produced at scale, a mere 15 months from start of construction to production. And this is the third materials company I've been CEO or founder of, and I am incredibly delighted to report that for the first time in my career that I've seen, 15 years doing materials companies, this plant is running months ahead of schedule. So kudos to the MycoWorks team. It's an incredible accomplishment. And it's just awesome to see this plant not only producing, but producing at a cost that's lower than what we even projected. So this is a very special plant. It's an incredible plant. It's the largest ever biomaterials plant. It's the largest alternative leather plant in terms of output. Many millions of square feet of fine mycelium produced each year on 136,000 square feet of floor plan, using 50,000 trays, and a slew of automated systems that we special purposed for our process, while leaving intact our key production operations, the savoir-faire, that yields our material's signature quality. So I'll explain a little bit about what's going on here. You see trays being manipulated in a work cell. Each tray is barcoded. So when we receive an order, we initiate that order deliberately to the specifications of the customer. Does the customer want a fabric embedded in the mycelium or not? Which thickness is it going to be grown to? And then ultimately the trays are delivered to humans where there are certain operations where there's human touch before the sheet comes off the line and the mycelium is harvested from it. It's an incredible process, one that has complete provenance and transparency from the start of the raw materials all the way through the tannery. But I would be remiss in not pointing out that a material actually needs one other thing to see success, which is performance, or the other type of quality, right? Performance and quality, subtly different. But performance is really about yields during production, consumer return rates, the economic side, the business side for brands who sell leather goods. And performance and scalability don't always go hand in hand. For many of us here, this has truly been the difficult part of the journey so far. So to tackle that problem, we stood alone many years ago in making the strategic choice to partner very closely with the downstream portion of this industry. Tanneries, fabricators, applications engineers, materials developers, designers. We chose to ship product as we scaled up. And sometimes that product wasn't performing well, right? We would do an experiment to test the scalability of something. We would have to ship product to fulfill the demands of a relationship, and we would ship it. And frankly, we lost some potential partners as a result. But we all learned a lot. The learnings were invaluable. We built a culture at MycoWorks where we constantly stress tested every aspect of our understanding of the material, how it was made, how it's used, everything about it. What we found was that tanning mycelium was extremely difficult. We never imagined it would be as hard of a problem as it was. But we kept at it. And so today, and to geek out for a second here, we're announcing a major breakthrough, a fundamentally new approach to tanning mycelium, which, for the first time, gives lubrication, penetration, fixation at levels only seen in advanced animal leathers to date. So what's the result? We have a full-scale plant now producing. Moreover, we have it running a process that yields high-quality, sustainable, and consistently high-performance biomaterials. So we're proud to reveal to you today, on display at our booth, the extremely difficult to fabricate Togo chair from our amazing French luxury furniture partner, Ligne Rosée, made with Reishi. And so one can look at this and ask, have we just replicated leather? Is it leather? Or is it something more, a new category? Is the value of a new biomaterial its physical performance, like martindale abrasion or Bali-Flex combined with a low carbon footprint? Or is it something much, much greater? What if we lived in a future where natural, high-quality materials are made to order, made to spec, tray by tray, lower waste, locally grown, with known provenance? This future is here with MycoWorks South Carolina. And we're not done. To really tap into the potential of biomaterials, it's important to understand just what it means to have an organism that has a structure as tunable as that of myceliums. We've started with our Fine Mycelium process that improves the tensile strength of mycelium by a factor of 10. But beyond that, imagine changing the composition of the cells, getting them to branch more, to wrap around themselves more, to form in ordered structures, or do something entirely different. That, creating a platform for fundamentally new things, is the holy grail of biomaterials. Some of this will be done via tuning the conditions in our trays and the things we do to the fine mycelium as it grows. But even cooler things can come from genetics. So what I'll leave you with is a glimpse into the not-so-distant future, where synthetic biology isn't used to simply produce new biochemicals, as was thus far unsuccessful in creating true biomaterials, but rather a future where SynBio is used to tune an existing system, mycelium. Here I'll show you two examples of what we can do with a simple gene knockout or splice. This is work we've been quietly performing for a couple years now internally and with a partner. First is a mycelium that fluoresces red. And this is a mycelium whose color we can tune. So the possibilities here are really endless. So, to come back to my original thought, should our goal be to replicate leather or to leapfrog it? I think you can now tell how we've been thinking about that at MycoWorks. And to this community, I have a question that I hope we can all discuss today and tomorrow. Should we continue to think about the adoption of biomaterials as a replacement problem, or is it really a design problem? Did nylon merely replace ancient materials? No, of course not. It spawned a new era of design, countless new products that grew the whole pie. So to the brands in this room, I say, if you're looking for a leather that isn't leather, you're going to be looking forever. Shouldn't we be designing materials for the world that we want to live in? This is the beauty of a design-forward field like fashion or luxury. So I'm convinced that together, with our unique position amongst all industries to look at problems with design thinking, we can usher in an entirely new age of biomaterials for the world. Thank you.
Thank you so much, Matt.